Right, so previously in 5.1, so I already explained to you what is a periodic function. So I told you that it's a function that repeats itself on a period value, which is a regular interval. And for 5.2, we're going to have a look at the graph of sine and cosine. And of course, so graph at sine and cosine. So those two are actually classic example of periodic function. So when you say periodic function, so sine and cosine is going to be a very example that everyone should know that it's actually a periodic function. And another term that is very important when we talk about periodic function is going to be amplitude. So here, let f be a periodic function, and m and capital M is actually the minimum and maximum values of the function. So here, the big M is actually the maximum, and the small m is actually the minimum value, so divide by 2. So that is going to be your amplitude value. So if I were to refer back to my example that I've shown you in 5.1 for the case of periodic function, so let's have a look at this one. So here we can identify that the maximum value is going to be at -3 and the minimum value is going to be at -6. So if I wanted to find what is going to be the amplitude, so the maximum is going to equal -3, so minus the maximum is going to be a value of the minimum value is going to be a value of -6, so divide by 2. So I will end up with -3 plus 6 divided by 2. So my amplitude value is going to equal 3/2. So that is going to be the amplitude value. Alright, so you just have to take the maximum value, so minus the minimum value, and divide that by 2, and it will give you the amplitude. And it's going to be very similar for the case of sine and cosine, so that is how you determine the amplitude value as well. So this is an example of graph of sine and cosine. So if you notice, the highest value will be at 1, the lowest value is going to be at -1. So if you were to apply the amplitude formula, so I'm going to end up with it's going to be 1 minus negative of 1 divided by 2. I'm not sure what's wrong with my pen today. So therefore, the value is going to equal 2/2. That is going to equal 1. So that is why the amplitude is going to equal 1. Okay, so this is the example of graph of sine looks like, and this is going to be for one cycle. And of course, if I were to extend it, so I'm going to have another cycle on this side, so exactly with the same shape on the other side as well, if I were to extend. But if I want only one cycle, okay, one period, so one period is going to equal 2 pi, and this is also known as being one cycle. How does one shape actually looks like? If I were to extend, of course there will be more cycle repeating over and over again. So that is going to be the case for periodic function. So actually, when you sketch for sine function, there are only a couple of things that you have to capture. So what do I mean by that? Okay, let's say this is going to be my axis, and sine function actually looks like this. So there is going to be 5 important points that you have to capture, which is going to be here, here, there's 3, 4, and 5. So you have to know the value of all of this. So that is going to help us when we go to 5.3 and 5.4. Okay, so this is going to be your x-axis. So this is going to be the y, or sometimes could be f of x, it doesn't matter. So let's say I'm going to put it as x and y. So this is going to be my x and y. So we have 5 values. 1, 2, 3. So these are all the values that you should know. Okay, so the first one is going to be over here, so which is 0. So when x is equal 0, y is also going to be 0. And over here, so this is going to be a value of pi over 2. So what happened is that at pi over 2, so your value of y is going to equal 1. Okay, so this is a basic graph of sine function. And then here, so this is going to be the case of pi. So what happened when you have sine of pi? So that is going to equal 0. And over here, this is going to be a value of 3 pi over 2. And what happened is that when you have 3 pi over 2, so the value is going to equal negative of 1. And here, this is going to be when x is equal to pi. And for this case, this is going to equal 0. So these are going to be 5 important points. So when you sketch your function, so you have to make sure that these 5 points are on point. Okay, so you don't have to actually remark everything that you have over here. So there are actually 1, 2, 3, 4 and 5 points that is going to be the most important in our function. Other than that, so that will be additional. But when you sketch, I want you to be very clear about the values of this 5 important points. So that is going to be for the case of sine. Okay, so this is a few cycles of what I call that sine function. So this is one cycle, so this is actually another cycle, and it's going to be repeating here again. Okay, so remember, every 2 pi distance, so that is going to be another cycle. The shape, it's going to repeat. So the characteristic, these are going to be the characteristic of sine function that we can observe. So the domain is going to be from negative infinity until infinity. There is no restriction. So your value of t over here, it could be anything, could be from negative infinity until infinity. So the range, so it's going to be from here until here, so that is going to be from negative 1 until 1. And the period value, as I mentioned to you before, so for the case of sine and cosine, they share the same period value, which is going to equal to pi. And this is actually an odd function, and you will learn this in detail later in your third mathematics course, which is known as applied mathematics. Later you will see what is odd and even, and the maximum value is going to be at 1, and the minimum value is going to be at negative of 1. So it's so if I were to consider in one cycle, which is going to be from 0 to pi, so it's going to be increasing, it's going up from here to here. Okay, so from 0 until pi over 2, and also from here to here, so which is 3 pi over 2 until 2 pi. But other than that, so on this side is actually going down, it's decreasing, and that is going to be from pi over 2 until 3 pi over 2. And what is going to be the zeros? The zeros is actually the x-intercept, so that is called as being the zeros. So it's actually the x-intercept. Those are called as being the zeros. And we are going to have zeros at every t equal k pi. So this is pi, this is 2 pi, this is 3 pi, 4 pi, and so on. Whenever k is an integer, so you're going to have an x-intercept whenever you are at that point. So that is going to be the characteristic of sine function. And then next we can have a look at cosine function. So it has a slightly different shape. Okay, so again, so there are multiple values over here. So we have pi over 2. Yeah, those are actually the most important point that you have to capture. So the period, one period is going to be from 0 until 2 pi. And for the case of sine, okay, let me sketch one cycle and show you which dots do we have to capture. So your cosine is somehow going to look like this. So this is a graph of cosine function, and there are how many points that you have to capture? 1, 2, 3, 4, and 5. So pretty much the same. It's going to be 5 of them. And of course, this is going to be 0. So this is going to be pi. Here, this is going to be pi. And here, this is going to be pi over 2. So this is going to be 3 pi over 2. And at the end over here, this is going to be a value of 2 pi. So what are the important values that you have to capture? So let's say this is going to be your x and y. Or it could also be x and f of x. It doesn't matter. So those are actually the same thing. 1, 2, 3, 4, and 5. So I have 0, pi over 2, pi over 2, and this is pi. This is going to be my 3 pi over 2, and the last one is going to equal 2 pi. Okay, what happened is that, so when this is 0, so my graph is actually up here, so that is going to be a value of 1. Pi over 2, my graph is right at the end on the axis, it's equal 0. And for negative pi, for x equal pi, the value is going to be down here, so which is the value of negative 1. So 3 pi over 2 is going to be at 0, and 2 pi is actually at a value of 1. So those, when I asked you to sketch for cosine function, so those are going to be the 5 important points that you have to capture. The rest of them, it doesn't really matter, but you need to have all these 5 clearly visualized on your graph. And in terms of the properties, so it's going to be the same idea as what we have seen for sine before. So the domain for t over here, there's no limitation. So the domain could be any value from negative infinity to infinity. The range is also the same as sine. So the highest value is going to be 1 and the lowest value is going to be -1. The period is going to equal 2 pi. So it's going to be increasing on this side. So starting from pi until 2 pi. And it's decreasing on this side, which is from 0 until pi. And where are going to be the zeros? So the zeros is going to be here. So it is on every pi over 2 plus pi k unit. So where k is an integer, whatever that is this value, so that is going to be an x-intercept on the graph. Okay, so basically those are going to be the characteristic of sine and cosine that you have to know. And do you have to know how to sketch this? Yes. So you have to know very well the basic of this, which is going to be this one and also this one right here. So please bear that in mind, because later, so we are going to extend the idea a little bit more and you have to be very